Let's look at some problems using these equations. Sound wave has a frequency of 205 Hz and travels the length of a soccer field, which is 95 meters, in 0.255 seconds. What is the speed of the wave? What is the wavelength of the wave? And what is the period of the wave? So as always, we start by writing down what we know. Frequency equals 205 Hz. Distance it's traveling is 95 seconds, or 95 meters, and the time 0.255 seconds. So to find velocity, we can do velocity equals distance over time. So in this case, our velocity equals 95.0 meters divided by 0.255 seconds. And before we round our answer, we have to think about significant figures. Both of these numbers have 3 significant figures, so we will round our answer to 373 meters per second. To find the wavelength, we would have to use this equation because it's the only equation we know with wavelength in it. So our velocity equals wavelength times our frequency. And we've written the units as hertz, but it's important to remember that that just means per second. Otherwise you won't see why we get the right number here. So we divide both sides by 205. And we realize we have to round to 3 significant figures. And dividing meters per second by per second means the seconds cancel out. And we get 1.82 meters. The last question is, what is the period of the wave? We don't have a whole lot of options here. The only equation we have with period is frequency equals 1 over period. So our frequency equals 1 over our period. To find the period, we do 1 divided by 205, and we can find that the period is very small, 0.00488 seconds. So the way those are related, remember the frequency means 205 waves pass a point in 1 second, and the period means that it takes 0.00488 seconds for one full wave to pass the point. Let's look at a second problem. Our second example here is a hiker shouts towards a cliff that is 450 meters away. If the echo is heard 2.75 seconds later, what is the speed of the sound wave? If the wavelength is 0.750 meters, what is the frequency? So let's write down what we know. And we know to find our velocity, we're going to have to do distance over time. But before I write anything down, let's think about we're doing an echo. So it has to travel this 450 meters to the cliff and 450 meters back. So our distance is 900 meters, and make sure you use the appropriate adding rules in order to get your significant figures here. And our time is 2.7 seconds, and we're going to need the wavelength in a little bit. 0.750 meters. So to find our velocity, we do velocity equals distance divided by time. So velocity equals 900 meters, 2.75 seconds. Our velocity is 327 meters per second. And we can look at our numbers. We can see this has 4 sig figs, this has 3, so our answer will have 3. In order to find the frequency, we have to use our other equation, velocity, wavelength times frequency. So 327 equals 0.750 meters times frequency. We're going to divide both sides by the 0.750, and the meters cancel out, giving us per second, which we call hertz. And with three significant figures, we have 436 hertz. Now I would count it right if you said 436 per seconds, or if you said hertz, because that's just two different ways of saying the exact same thing.